All right, let's get some practice. The empirical rule, otherwise known as the 68, 95, 99.7% rule, which is a really silly name for a rule. Let's call it the empirical rule, is a good way to get an idea of how rare something is and just a general rule of thumb, because normal probabilities of normally distributed random variables are actually really hard to calculate. In fact, nobody can calculate them by hand. Nobody. Okay? We can approximate them by hand, and we can use computers to help with this, but yeah, these are wacky probabilities. The math behind it's pretty weird. So empirical rule is very useful. So to get some practice, let's, well, I already did this for you, drawing, labeling the model. We're doing the same Portland model. But now I want you to also shade the area. And remember that, well, not, I always say remember. It's remembering for me. I've taught this before. It probably is new to you. The area and the percentage are the same. Whenever we do these, when we draw pictures, area and probabilities are really going to be the same thing. We'll talk more about that later that you want to find. So again, same average annual rainfall, same standard deviation of rainfall. Let's do some probability questions. So according to this, what percentage of the time is the annual rainfall between 32 and 48 inches? What percent of the time are we in this blue area? Well, how much of the total area is shaded blue? That's the same thing as what percentage of the time we're in there. It's the same thing as the probability that we're in there. And well, we know this is one standard deviation above the mean, one standard deviation below the mean. We use the empirical rule to say, okay, about 68% of the time. Okay, within one standard deviation of the mean. And we can do this for the other ones and be a little bit more creative sometimes. So letter B now is asking, okay, what's the probability that the annual rainfall is more than 48 inches? What's the probability now that we're in this blue area? Well, now we have a couple of steps to do. Let's use what we know about part A, right? Part A says that about 68% is in this blue area. So then, how much is in the green area? Well, green plus blue is everything. So 60% is inside, 32% has to be outside. Well, notice the relationship between this green area and this blue area. This is symmetric. So if that's the case, that means that this has to have 16% and that has to have 16%. Like a little geometry problem. So we use part A to say that this is about 16%. Can you use this logic to do part C? Try to pause the video, work on part C on your own. Let's see if we can get the same thing. What percentage of the time is the annual rainfall 24 inches or less? So it's going to be a pretty small area, right? We should expect a pretty unlikely probability. Now we're going to do it in some steps. Okay. So let's start by looking at this green area. Green is within 2 standard deviations of the mean. And we know from the empirical rule that 95% of the data is in green. Well, that means 5%, right, is outside of green. Well, we have 5. that means that red plus blue is 5%, and red and blue are the same. So we know that blue, right, blue is half of this, 2.5%. That's how we can find the likelihood of this with the empirical rule. Kind of cool, right? Not any fancy math, just like a little geometry here. Now E, we can't really use the empirical rule to give us something amazing, but let's give an estimate. 54 inches or less. Okay, 54 inches, that's like 3/4 of the way between 48, 56. Now this one's going to be a little bit more complicated. Okay, well, let's start with what we know. Between green, that's 2 standard deviations of the mean. That's 95%. 95% in this green region. And we know over here, right, if we go all the way to the left of that, that'll be 2.5%, just like we did up here. Because there's 2.5% on either side. So what we want, blue is almost green plus red, right? This whole blue area. But then there's this kind of leftover yellow that we have to kind of subtract out. And that's kind of hard. We have to estimate it. We don't know how big yellow is. So you could do that in a couple different ways. I'm going to say 97.5% is less than 56 inches. And then you could also, if you really wanted a better estimate, figure out what this yellow area is. We could do that yellow area exactly and then kind of approximate it. I'm just going to say, okay, 97.5 is the whole area. Let's try to subtract out something. Let's approximate something smaller than 97.5. You could say 97%, 96%, maybe say 96.5%. I don't know. But something around there is how you could approximate, get an idea of this. So everyone might have different answers, but they should be kind of somewhere around there. And in the next video, we're going to talk about how to find these probabilities. I won't say exactly, because we're still approximating, but much more precisely, shall we say, okay? But this is how you can use the empirical rule and pictures to find probabilities. And remember that area, what percentage of the area is under the curve, and what's the probability of this happening are really kind of the same thing here. So getting these pictures is going to be very useful. Anyway, until next time. I've been saying that a lot on these videos. Maybe I'll say something cool like, take it easy. Or so, I don't know if that's cool. Bye.